Hello everyone, today we're going to learn how to derive the quadratic formula. The quadratic formula is based upon the process of completing the square. Today we will review how to complete the square and generalize the process in order to derive the quadratic formula. This should answer the question, how did they come up with this? So on the left-hand side is the example, and on the right is the derivation of the quadratic formula. So you're going to subtract the constant to the right side. So we have ax squared plus bx equals negative c. Divide each side by a. You get x squared plus b over ax is equal to negative c over a. Then you're going to add b over 2 squared to both sides. So you're kind of doing b over 4 because it's b over 2a. So it'll be b over 2a squared to both sides, which will be x plus b over ax plus b over 2a squared equals negative c over a plus b over 2a squared. Simplify that to x squared plus b over ax plus b squared over 4a squared is equal to negative c over a plus b squared over 4a squared. And again, I want these to have a common denominator, so I'm going to multiply top and bottom by 4a so I can combine my like terms there. So now I'm going to factor, and it's always going to factor to x plus b over 2. So it's going to be x plus b over 2a squared is equal to negative c times 4a is negative 4ac plus b squared all over 4a squared. Starts to look a little familiar, right? Square root both sides, and you get x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, because I kind of like that order a little bit better. All over the square root of 4 is 2, and the square root of a squared is just a. Then you're going to subtract by b over 2a to both sides. And you get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, and simplify. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is how we came up with the quadratic formula. We're going to do a couple of solving quadratics based on when you have imaginary solutions. So we're going to do the first one together, and you're going to do some on your own. First thing you're going to do is you're going to set equal to 0. So I'm going to add 9 to both sides. So I have 10n squared minus 6n plus 9 is equal to 0. So our quadratic formula is at the bottom here that we are now going to be able to use, and we know how it came up with it. So my a is 10, my b is negative 6, and my c is 9. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I do my inside the radical, my radicand first. So I get x equals, and negative times negative is a positive 6, plus or minus the square root. Negative 6 squared is 36. 4 times 9 is 360. 360. 36 times 10 is 360. All over 2 times 10, which is 20. So you always want to do what's in the radical first. So 36 times 360. And you get x equals 6 plus or minus the square root of 324 all over 20. And it's negative 324. And 324 has a common factor. And again, we have to simplify our radical sign. So it's really important here that you simplify your radical sign. And the square root of 324 actually becomes 18. So we have x equals 6 plus or minus 18, because the square root of 324 is 18. But because you have the square root of a negative, this is the square root of 324 times the square root of a negative 1, which we learned is I, all over 20. You cannot combine unlike terms, but you can simplify this fraction. We can divide everything by 2, and you're going to get x equals 3 plus or minus 9i all over 10. And that would be an example about solving a quadratic with imaginary solution. I want you to try now on your own, and we'll go over in class tomorrow. Bye, everyone.